Hello, students. Welcome to your Chapter 6 review video. This is going to be pretty much just a place for me to go over all the different things that we talked about in Chapter 6 before we have to take our test on Wednesday. So I'm just going to go through each section that we covered and sort of what we dealt with. This is going to be a place where you can see all of your theorems and properties and things like that. And, you know, obviously you have some review problems to be working on today as well, and that will help you to apply these different things. Okay, so I'm not going to do any actual example problems here, but this is just a place for you to find all your information all centrally located, so you don't have to go back to each one of the Chapter 6 videos. So this chapter began just talking about polygons and a generally broad discussion of them, specifically about angles inside of a polygon. The first thing that we talked about was we took polygons and divided them into triangles in that first video, and we arrived at this formula here for the total sum. If we add together all the interior angles of any polygon, it's this formula here, n minus 2 times 180 degrees, where n is the number of sides. So that allows us to find the total for the interior angles of a polygon. We also talked in this section about a regular polygon, meaning all of the angles being the same, and finding each measure of the interior angles in a regular polygon. That simply takes this and then divides it by n. Okay, so there's that formula as well in section 6.1. And then we talked also about exterior angles. Okay, and remember, exterior angles were always the same. They always add up to be 360, no matter how many sides the shape has. So these two theorems are sort of the main things that we applied in section 6.1 about the angles in a polygon, or the exterior angles of them. And then the rest of the chapter, we've been talking mostly about special quadrilaterals. Okay, quadrilateral meaning four-sided shape. So we started in section 6.2 and 6.3 talking about parallelograms. Remember that section 6.2 was the properties of a parallelogram, like what we know if we have a parallelogram, and then section 6.3 was asking us to use those properties to prove that something was a parallelogram. And then this concept summary comes from section 6.3. And it shows you the 6 different ways that we had to show or to prove that something is a parallelogram. We had the definition that both pairs of opposite sides are parallel. We had the 4 properties about opposite sides being congruent, consecutive angles, supplementary, opposite angles being congruent, the diagonals bisecting each other or cutting each other in half. And then we had this one theorem that said if we prove that one pair of opposite sides is both congruent and parallel, that's enough to show that that's a parallelogram. Okay, so we did a lot of algebra in these 2 sections, using these different properties and using these properties to prove that something is a parallelogram. In section 6.4 and 6.5, we talked about more specific special types of parallelograms. Rectangles, rhombuses, and squares. So remember that by definition, a rhombus has 4 congruent sides. By definition, a rectangle has 4 right angles, 4 90-degree angles. And then a square has to be both of those things, a rectangle and a rhombus. And then we had a couple of properties for each one. So rhombus property 1 was the diagonals have to meet at a 90-degree angle in a rhombus. Rhombus property 2 was that the diagonals have to cut the corners into equal pieces. They have to bisect the opposite angles in those corners. And then our property about rectangles was that the diagonals' lengths are actually congruent. And we also talked about the fact they are a parallelogram, so all of these are also congruent, each of those 4 pieces. And then, as I mentioned, squares have all the properties of the rectangles and the rhombuses, and of course, all the properties of parallelograms as well. Again, we did a lot of algebra here, and we also did a lot of yeses and nos. Can we determine that this is a rhombus? Or look at this shape, what type of shape do you know that this is? And our answers would say rhombus or parallelogram or square or whatever, okay? When we got to section 6-6, we sort of left the world of parallelograms and we talked about two other types of special quadrilaterals. One was a trapezoid where we had one pair of parallel sides, but the other pair was not parallel. And then we talked also about kites, which was, remember, two pairs of consecutive congruent sides. So like this was the same as this, and then it was sort of extended out this way. And then this was the same as this here, okay? So trapezoids and kites. We had a couple properties of those as well, which I've listed here. The trapezoid properties were only about isosceles trapezoids. And remember, that means that the two legs, meaning the two not congruent sides, would be congruent to each other. The two non-parallel sides are congruent. So in those isosceles trapezoids, we have base angles that are congruent. And remember, base angles are just any angles along the base. So down here across the bottom or up on the top, those angles along the same base have to be congruent. And then also the length of the diagonals is congruent. But the difference here from a rectangle, remember, is a rectangle had to be a parallelogram. In this case, this is not a parallelogram, but these diagonal lengths are the same. Okay, in a kite, the diagonals are perpendicular, so they have to meet at a 90-degree angle, just like in a rhombus. But again, a rhombus is a parallelogram, and this isn't. And then the diagonals make three pairs of congruent triangles. So we talked a lot about congruent triangles with a kite. If you draw the diagonals, you have a lot of congruent triangles, and therefore a lot of congruent pieces of those triangles. So yeah, do remember that as well. And then the only other thing we talked about in terms of trapezoids was we talked about the mid-segment of a trapezoid. And that, remember, was the line across the trapezoid that connected the two midpoints of the legs. Okay, not the bases, but of the legs. And we knew that that mid-segment across the middle of the trapezoid was parallel to both the top and the bottom base, and that it was half as much as the two bases added together, right? Half as much. Or the other way that we looked at that was if we double the middle segment times it by 2, that has to equal the top and the bottom base added together, okay? So remind yourself about that. You should be able to find some practice problems from section 6-6 about trapezoid midsegments. And then section 6-7, we just talked about all of these different kinds of shapes in a coordinate grid, okay, in a coordinate plane. So remember, we used the distance formula, we used the midpoint formula, we used the slope formula to try to determine all of these things and decide, given these four corners or four coordinate points, what type of quadrilateral is this, okay? So we had to maybe plot the points and then connect them and see, okay, do we have sides that are the same length? Do we have sides that are parallel, et cetera, okay? So that, in a nutshell, just in terms of super quick review, gives us all of chapter 6, okay? From polygon angles all the way down to plotting 4-sided and 3-sided shapes in a coordinate grid and determining what we can classify them as, okay? If you have any questions, particularly about your review problems today, please do reach out to me and ask. Today or tomorrow or even Wednesday during the day. Your test will be Wednesday, and if you don't have any questions, you should be ready to go. All right, so like I said, we will talk to you soon, and that's all I have for you right now.